Today we are going to be working on prime and composite numbers. You should have a couple of things in front of you. You should have a pencil, a piece of notebook paper for notes, and you should have a hundreds chart. Our goal for today, we know we've been focusing on how patterns help us find factors and multiples. Today we're going to use those two new words, prime and composite, to find out some more information about numbers. A prime number is a whole number greater than 1 that has exactly two factors, 1 and itself. A composite number is a whole number greater than 1 that has more than two factors. Pause the video and write down the definition for those two words. Now let's look at some factors of 12. If you remember, a factor of 12 or a factor is any two numbers that will equal 12. So I know that 1 and 12 equal 12. I can multiply 2 times 6 to get 12. And I can also multiply 3 times 4 to get 12. But when I think of factors of 13, the only number I can put together is 1 and 13. So I can say that 12 is a composite number because it has more than two factors. 13, however, is a prime number because the only factors are 1 and itself. Let's try these in a couple of different examples. I'm going to go back and I want you to be thinking about what you've learned about divisibility. You've learned a bunch of divisibility rules yesterday, and we're going to put them to use today. If a number is divisible by any other number than 1 in itself, shazam, it's composite. Once I've proved that a number is composite, that means it can't be prime. It's kind of like one or the other, like odd or even. A number can't be odd and even, so we're going to use those exact examples to help us figure out for prime and composite. So let's think about 51. Is 51 divisible by 2? It's an odd number, so no, 51 is not divisible by 2. Is 51 divisible by 3? Let's think. I could do it the long way. 3 can go into 5 once. Oh, it is by 17. Oh, you know what? I could have used my divisibility rules. I could have taken 5 plus 1 equals 6. If 6 is divisible by 3, and it is, 51 is divisible by 3. So it is. So once I have found that 51 can be divided by another number other than 1 in itself, it's automatically composite. So in this example, we used divisibility rules. Did you see how easy that was? Instead of this? Oh, you know I'm going to be using divisibility rules for my next couple of practice problems. Let's take a look at one. Here, I'm thinking of 18. And I'm asking myself, is 18 composite or is it prime? I know there are some factors of 18. I can think of 1 and 18. But I can also see that 18 is an even number. So 2 times 9 is 18. So I can say, since I have found another set of factors, 18 is composite. If I wanted to prove it, I would simply write because 2 times 9 equals 18. I could also say it's composite because 3 and 6 are factors, or 3 times 6 equals 18. So this is the proof. Because I found other factors besides 1 and 18, 18 is a composite number. Now, let's try some more practice with our friend prime. Here we go. I've got 19. Let's see. It is not an even number. So that means it cannot be divided, or 2 is not a factor. 1 plus 9 equals 10. So that means, and 10 cannot be divided by 3. So 3 is not a factor. If 2 and 3 are not factors, then 6 isn't a factor. I know that I can't add 1 plus 9, or 1 plus 9 is 10. 10 cannot be divided by 9. So 9 is not a factor. If I count by 7s, 7, 14, 21, 7 is not a factor. The only factor for 19 is 1 and 19. So that means, my friends, it is prime. If we look at 92, I know that 2 at the end of this number makes it an even number. That means that 2 is a factor of 92. Once I know that, I can say it is composite. Now here's my proof. 92 is an even number. So 2 is a factor. Now my next example is 47. Oh, it's not even. Oh, that makes my work a little harder. So then I have to think, okay, 4 plus 7 equals 11. 11 is not divisible by 3. 11 is not divisible by 9. 11, oh, let's see, 4, it's not an even number, so it can't be 4. It's not an even number, so it can't be 8. And I know that 7 times 7 is 49. So there are no other factors for 47 except for 1 and itself. So I have myself a prime number. Now we're going to get out that hundreds chart to help us find some prime numbers. What I'd like for you to do first is we're going to cross out 1 because it is not a prime number. Now you're going to circle 2 because it is prime. Then we're going to cross off all other multiples of 2. So I would cross out 4, 6, 8, 10, 12, 14, 16, 18, 20, and I see myself a pattern. It's going to be all of these crossed out, all of these, all of these, and these, and these. Let's look at our next. We've crossed out 1 and circled 2. We got rid of all of these, and these, and these, and these, and these. Now we're going to circle 3, and I'm going to cross off every other multiple of 3, which would be 6, 9, 12, 15, 18, 21, 24, 27, and 30, 33, 36, 39, 42, 45, 48, 51, 54, 57, and 60, 63, 66, 69, 72, 75, 78, 81, 84, 87, 90, 93, 96, 99. Oh, did you see this pattern? I didn't see that until just now. Look at that. There we go. Okay, so now I've got all of those marked off. Now let's take a look at what our next job is. We had circled 1. We had X'd off 1. We had circled 2. We had circled 3. You remember, I got rid of all of these. I got rid of all of these. And all of these. You guys are so lucky you've got that paper in front of you. And these. And these. And then I found that handy dandy little, I think it was right here. Right there. I had one right here. And right here. And right here. 251. Okay, there we go. Sorry, this is taking me a long time. Okay, so now I'm going to continue crossing out every other number until it's done. So now I'm going to look at 5. 5 is prime, not 10, not 15, not 20, not 25, not 30, not 35, not 40. Oh, I see another pattern. I'm going to go ahead and make myself faster right now. Okay, all of these. Now I'm looking at 7, and I'm going to cross off. Not 14, not 21, not 28. So I'm continuing to go through, and now I can see, really, I've used up almost all of my numbers. So when you look and you keep going, you're going to finish this on your own. And let's take a look to see which numbers you have left. Here are the numbers that are prime. 2, 3, 5, 7. The list goes on. You'll notice that after this, we do not have any other even numbers. But all of these numbers only have 1 and itself as factors. Now it's time to check your understanding of prime and composite numbers. You're going to complete the lesson check that accompanies today's video. Be sure to include those work for the problems you might need to show your proof. Find those factors, and then Mrs. Sheridan or your teacher for math, maybe Miss Dilworth or Miss Welt or Miss Reddy, they'll be looking to see how you can review those problems to start your math lesson. Good luck, and keep it prime.